becomes attractive to us because if we now have a cloud computing model, we can scale across all these computers to make all of these requests for us, and it's costing us very little. In fact, if you're attacking a service that's built on Amazon Web Services, then all traffic from Amazon Web Services to Amazon Web Services is free. So you can build your brute forcer in the cloud and not pay for any traffic while you brute force attack someone. Okay, so this was one of the things we wanted to do. So I ported our old Crowbar so that you now have a cloud version of it, so that Crowbar now lives in the cloud. You can click a button and say, bring more friends. It basically invites other cloud computing accounts of yours. So instead of one Crowbar account, you now scale this across as many as you want to pay for. The problem is that I was wrong. Okay, so if you take a look at, while the screen adjusts, if you take a look at our first example, which is basically SugarSync. Okay, so if you go to SugarSync and go to request I forgot my password, essentially what happens is they say, okay, we're going to mail you back your password. Okay, so time goes on, you should see the email coming through down there, which is a simple one of those reset links. Okay, you take a look at the reset link, it looks something like that. You click on that link and it now allows you to go reset your password. Okay, what's interesting for me as an attacker is how small that secret portion is. Okay, because essentially it gives me hope that I can brute force through that space. Okay, so what I'm hoping for is to go reset someone's account, that link gets sent to them, and then using my new cloud tool, I'll brute force through that space till I find the correct URL that will allow me to reset his password. Okay, does anyone know how I was wrong about this? Anyone? Okay, the simple way that I was wrong is, that my slide didn't work. The simple way that I was wrong is, even though that looks small, it's still a pretty big space to iterate through. Okay, it gives you 35 to the 12 possibilities. You're still not going to brute force through that easily. Okay, even if you use the birthday attack, you're still dealing with a number that's too big because that link is active for 2 days. Okay, so I visit them, I say, I want to attack this person, he forgot his password, they send the link. I iterate through those so that they send him lots of links. Okay, but still, they can't send me exhaustively through that space in the 2 days that I have to test. But during the testing, I've already gone down this route. I really wanted to break into them, so we kept trying. So we generated a whole bunch of requests, hoping that we could find some weakness, some predictability in that number, and it turns out actually we couldn't, and so that was a fail. But while we were doing this, we figured out something else, that we could script the account reset process fairly easily. Okay, we use Twill for this. If you haven't used Twill for web app testing, you should Google it, download it. It'll save you a lot of time. But basically what we figured out is if we scale this across EC2, we could get something like 2 million I forgot my password requests sent inside of 2 days. So we did to see if they'd notice, and they didn't. Okay, so basically if you imagine this attack plan, I want to break into Bob's directory store. I go in, I say Bob forgot his password. I say that 2 million times. And so all the time they're sending valid links to him. And at the same time I'm running Crowbar guessing for valid links. So I'm attacking the problem from both ends. On one end I'm creating a lot of links that should be active. On the other end I'm trying to find a link that's active. Sooner or later I find one that works and I can log in. Okay, at this point I'm really stretching. But what's interesting to note is while we were doing this testing, so we did it, we went through it, they're already making a mistake in that they're not detecting that we're pulling this attack off. Okay, and something that's interesting to note is this becomes a problem more and more when you look at cloud computing, is that you're not even aware that you're under attack. Okay, in this instance, we go back and look at our SugarSync email folder, okay, and we go back and we find here's all of the mails that were sent to us with valid links for us to go back and reset our password. We take a random one, okay, and it turns out that that link is still active. So we can go back and reset our SugarSync password. What's interesting for us is that at this point, if you look at the email date there, that link was generated on the 2nd of July, and our current date at the time of this testing was the 16th of July. So it turns out that those links are valid forever. Okay? So SugarSync weren't resetting the count on that thing. So we could now categorically just keep running generating forgot password links, keep going at the other end, and you guarantee that you'll eventually find a winner because nobody's going to notice that you're even doing it. Okay, which takes us to the next thing, which is platform as a service. Okay, and in this case, we want to look specifically at Salesforce.com. Okay, if we take Salesforce.com as an example, I'm going to blitz through this. They do both software as a service and platform as a service. Okay, we decided to take a look at their web application, and one of the first things that we found is that their applications are vulnerable to clickjacking attacks. Okay, at this point, we're doing really simple cursory testing because you bump into the problem that if Salesforce find you doing nasty stuff on their site, Salesforce is going to kick you off. Okay, we've got a video of the clickjacking attack, which I'm going to skip. All of you know what clickjacking is. Jeremiah did a talk here last year on it. If not, I'll make the video available shortly. Okay, and the reason I'm moving on is because we've got much more attacks than the time is going to allow for. So Salesforce have a problem in that Salesforce have a multi-tenant model. Okay, so multiple people all have their accounts on Salesforce.com. It's a subscription model. They also have some sort of app exchange. So people write apps and then you integrate their app into your CRM. Okay, already that should sound like a pretty bad idea. And one of the things that we enjoy as testers is they give you free dev accounts. So you can sign up for free and test Salesforce.com for free. Okay, and one of the first things that we wanted was to see how we develop an app for Salesforce. Okay, and they have a really simple to understand HTML templating language which you can use, and they have a Java-like language called Apex. Okay, and this is all custom that you've got to learn if you want to build apps for them. They also do their own type of SQL, which uses ORM, which we won't get into right now. You do your dev in a browser or through an Eclipse plugin. Okay, it's a really robust programming environment. For us as testers, basically if you look at the interfaces that are open to you, if you write an app that lives in Salesforce's cloud, you can then create SOAP endpoints, you can make HTTP requests, you can send emails out. Okay, and basically what we were looking for as attackers is if this multi-tenancy model exists, how can we as an attacker start to steal more than our fair share of computing time on Salesforce's cloud? Okay, all of this testing was done by someone much cleverer than me. So if you have any questions, you're going to have to go to marco@sensepost.com. Basically, Salesforce have something called the governor, where the governor sits and tries to make sure that one person doesn't use more computing resources than they should. They limit this on a whole bunch of things. So you're only allowed to make so many HTTP requests. You're only allowed to use so many lines of code. You're only allowed to make so many emails per day. Okay, and some of these limits, they don't tell you what they are. So the first thing that we were looking for was how we could push past the governor. Okay, how we could steal more computing time on the Salesforce cloud. And to do this, we'd need to introduce some new primitives into Salesforce.com. Okay, we'd need to find a way to get delays, find a way to get synchronization. And almost all of these can be built just with a little bit of evilness and a little bit of dedication. So what you'll see there is, it turned out that even though Salesforce limit your lines of code, they don't limit how many instructions you put per line. Okay, so with a lot of instructions per line, you bypass a really simple limit. And what we've got there is a whole bunch of mat functions chained together to simulate a sleep. Okay, we basically give it a lot of work. It's going to take a lot of work to do it. We've now got a sleep. Okay, we can then use the database for synchronization. Okay, so we can set a flag. Effectively, we're building a very ghetto-like mutex. Okay, so what we wanted was to have some way to give our code in Salesforce.com an instruction and have it carry on almost forever. Okay, but obviously they're blocking this. What we found though is that with their use of email, we could send an email into the system, have it do some work, then store state in the database once it's reached its limit, and then have it email itself to say, hey, do some work, here's your last state. Okay, essentially what you're creating is a loop inside of Salesforce.com that'll keep going and keep doing your work for you. Okay, once we've built all these things, we've essentially got a loop. We can tell it to do any work for us, and it's going to keep doing it. So one of the things we questioned was what we could do for proof of concept, and what we settled on was something called Sifto. Okay, we took the popular Nikto CGI scanner and we ported it into Salesforce.com, so Nikto lives in their cloud. Okay, the thing to remember here is that this is proof of concept. We could have done anything. Essentially, we're using free computing time that now belongs to Salesforce.com. Okay, so if you take a look at this example, and I'm going to go through it really quickly, we've already built up this in Salesforce.com's cloud, and we're using a simple wrapper here so that when we give it a target, it emails that target to our Salesforce application. Okay, and then we're tailing the Apache log file on a victim so that you can see these requests come through. Okay, what you'll see is we kicked off our scan. Salesforce.com now starts sending these CGI requests to our victim, and the moment Salesforce.com picks up a hit in the normal way that Nikto does, it then sends us an email to say, hey, I found this location on that web server. Okay, essentially you're getting the same results that you would from a Nikto test, except this now lives completely on Salesforce.com and is completely free for us. Okay, as attackers who live in South Africa where bandwidth is really expensive, this becomes attractive because it's almost as fast as the lines that we use at home. Okay, but essentially what this means is we can take any application, port it into Salesforce's cloud, and use their computing time to run our applications for us. Okay, so all we're doing there is stealing from Salesforce. Okay, so we're going to steal from a few more vendors really quickly. Quickly, the pros and cons of this sort of attack is it's really simple for us. One of the problems is there are still limits on how many emails you can send. Okay, Salesforce do have it, but it's unpublished. And so what we were looking for was how we could get more accounts from Salesforce.com. Okay, we wanted to sign up for more accounts, and it turns out that on their sign up page, Salesforce.com throw you back a captcha. Okay, so obviously this slows us down. We wanted to automate our way through this, but they've got a captcha. We do a really quick check, and if you look at the stream that comes back from Salesforce during the sign up, what we found, or what Marco found, is down here. They've got a little debug code called S-code, and what they're actually giving you there is the value of their captcha. Okay, so basically with wget, you can read the captcha and automate it. To their credit, we reported it to Salesforce and they had it fixed literally within minutes. Okay, but what it means to us as attackers is we can now scale horizontally. Okay, we can now create 200 accounts and spread our workload with all of those accounts because essentially we're building state fakely. Okay, so this gives us lots of possibilities, lots of interestingness. When you look at something like Salesforce, one of the things that should scare you is that Salesforce don't sell to security guys. Okay, they sell to sales or sell to marketing. And essentially, these security decisions start getting made by C-level execs in your organization. Okay, which should scare you a little bit. We're going to go next to Amazon Web Services. And like I said at the start, something I want to point out is Amazon Web Services is probably some of the coolest technology that I've played with in a really long time. Okay, if you haven't, you should sign up and play with it. It's lots of fun. The pieces that we're going to play with, we're going to look at EC2, S3, SQS, and DevPay. We're not going to look at the rest of them. Because I'm short of time, I'll go through this quickly. EC2, the Elastic Compute Cloud, basically allows you to hit a web page, say I want 10 boxes that look like this, they boot those boxes for you, and suddenly you've got boxes that you can use on the internet. Okay, it's really cool. S3 is their storage service.